These are notes from Elham's Math 60, Thursday, April the 9th, section 7.7 on complex numbers, page 660. This is the last section of chapter 7. Tomorrow, the 10th, Friday the 10th, will be the chapter 7 exam. Again, it'll be open book and notes, but no discussion. In 7.7, we're dealing with taking square roots of negative numbers, and we said before we cannot do that as far as real numbers is concerned, and that's still true. We're inventing a number called I. I is defined to be the square root of -1, and we'll see that happen in several instances here. It's not a real number, it's called an imaginary number, and we'll see what happens in situations like that. So for instance, problem 17, the square root of -9, before we just said stop, can't do it, not a real number. We're still going to say it's not a real number, but what happens is this negative, I'm going to pretend it's -1 times 9, and so I have the square root of -1, which is defined to be I standing for imaginary. It's not a real number. So when you have the square root of a negative, just take the negative outside and make it stand up as an I, leave the 9 inside. So I radical 9. Again, I is defined to be the square root of -1, and the square root of 9 is 3, so my final answer is 3I. For problem 23, what's important for negative square root of -72, this is not an instance of a double negative, so don't just make this into a positive. We're not allowed to do that. What we have to do here is what we did over here. Leave that negative outside alone, but the negative inside comes outside and becomes an I. So negative, this negative becomes an I, radical 72. Then I break down radical 72 like I have in the past. I can think of 72 as 36 times 2, and the reason why I want to do that is because 36 happens to be a perfect square, namely 6. So I take outside a 6, so I have -6I radical 2. 33a, something similar. This is not a double negative. Leave the 76 alone, leave that minus alone, leave the 54 alone, but the negative will come outside and become an I. Again, think of this as -1 times 54. The square root of -1 is I. So I comes outside. Then I try to fiddle with this 54. The square root of 54, well, 54 is 9 times 6, and then the square root of 9 will come outside and become a 3. So my final answer is 76 minus 3I radical 6. 41, 7 minus 3I minus 4 plus 2I. I will distribute the negative here, so leave this one alone, 7 minus 3I, but this becomes minus 4 minus 2I. And then I just combine the real part, 7 minus 4 is 3, and I combine the imaginary parts, -3I minus 2I is -5I, and that's about it. 43 is similar. First I have to convert that into some I form, and likewise for this one. So for this one, square root of -25, bring the negative outside as an I, so I radical 25. Likewise here, take out the negative as an I radical 4. And the square root of 25 is 5, so I can write this as 8 plus 5I. I can write this as 2 plus I. And now this problem looks very much like this one. So 8 plus 5I minus 7 minus 2I. So again, I just combine the real numbers, 8 minus 7 is 1. And I do the imaginary parts, 5I minus 2I is 3I, so 1 plus 3I. Coming over here, one thing to note, you're not allowed to just multiply these two. In other words, you might say, can I just go -2 times -12? No, you're not. The rule for this kind of situation is you always have to convert this to an I. So this negative comes outside as an I, so I have I radical 2. And likewise, this negative comes outside and becomes I radical 12. So now I have I times I, which is I squared, and square root of 2 times the square root of 12 is the square root of 24. And now anytime you see an I squared, that becomes a -1. I is defined to be the square root of -1, which means if I were to square I times itself, I get the real number -1. So I squared is going to be -1. That's going to be a recurring theme elsewhere in the rest of this homework. And then 24 I'm going to write as 4 times 6 because the square root of 4 becomes a 2. So my answer is -1 times 2, or -2 radical 6. 53 looks like a distributive property. So 2I times that, 2I times that. 2I times 7 is 14I. 2I times -3I is -6I squared. And once again, anytime you get an I squared, you change that to a -1. I squared is equal to -1. So -6 times -1 is +6. So we write the answer as 6 plus 14I. So the book makes an emphasis of this. This is sometimes called a complex number. there's a real part and an imaginary part. We normally write the real part first. The real part doesn't have any I. And then we add the imaginary part. So real 6 plus imaginary 14i. This whole thing is called a complex number. It's made up of a real part and an imaginary part. 59, 3 minus 2i times 2 plus 3i is just a regular FOIL. So first 3 times 2 is 6. Outer 3 times 3i is 9i. Inner negative 2i times 2 is negative 4i. Last negative 2i times 3i is negative 6i squared. And once again, anytime you get an I squared, you change that to negative 1. And I see 9i minus 4i is 5i, but I have negative 6 times negative 1, which becomes a positive 6 the next step. And 6 plus 6 is 12, so 12 plus 5i. Again, this is the standard form. You put the real part and then the imaginary part. 65, it asks for something called the conjugate. The conjugate of 2 plus 6i is 2 minus 6i. So for a conjugate or complex conjugate, you leave the real part alone, so 2 stays the same, but you change the sign of the imaginary part. So the conjugate of 2 plus 6i is 2 minus 6i. And likewise, the conjugate of 2 minus 6i is 2 plus 6i. They ask you to multiply these two. So I multiply 2 plus 6i times 2 minus 6i. That looks like a plus b, a minus b. So I just have to do 2 squared, which is 4, minus 6i times 6i. That's a negative 36i squared. And once again, I squared is negative 1. So I have 4 minus 36 times negative 1. That's like 40. That's like 4 plus 36. So my final answer is the real number 40. Okay, now I use that principle to simplify 75. We're supposed to write this with a nice denominator, simplify the denominator. So the original problem was 7 plus 4i over 2 minus 5i. The trick for rationalizing the denominator is to multiply by the complex conjugate of the denominator. The conjugate of 2 minus 5i is 2 plus 5i. So I put 2 plus 5i over 2 plus 5i. These are called complex conjugates. So in the denominator, it again looks like a minus b, a plus b, which is a squared, 2 times 2 is 4, minus b squared, minus 25i squared. That's going to come out to be a nice number. Numerator I just FOIL. 7 times 2 is 14. 7 times 5i is 35i. 4i times 2 is 8i. 4i times 5i is 20i squared. And then I go about simplifying. And 35i plus 8i is 43i. And 20 times I squared, again, I squared is negative 1, so 20 times negative 1. And likewise in the denominator, this I squared becomes a negative 1. So if I continue up here, I basically have 4 plus 25 in the denominator. So I get a nice denominator. It's going to be 29. And this looks like it's going to become negative 20. So 14 plus 43i minus 20. That gives me negative 6 plus 43i over 29. That's sort of the answer, except they want us to write the answer in the form of a plus bi. Write it as a real number plus an imaginary number. So I just split the 29 into two parts. Negative 6 over 29, that's considered the real part. And then plus 43 over 29i, that's considered the imaginary part. So this is the way we write the answer. 81, 8 plus radical negative 144 over 2 plus radical negative 9. Again, the negative comes outside and changes to an I. Same thing over here. And then the square root of 144 is 12. Square root of 9 is 3. So I have 8 plus 12i over 2 plus 3i. In this particular case, it comes out nice because you can factor a 4 out of the numerator. If I take out a 4, you have 2 plus 3i. Very conveniently, that cancels a 2 plus 3i here. So the answer is 4. The only tricky thing is they tell you to write the answer as a real plus an imaginary part. There is no imaginary part, so I put it as a 0. So in so-called a plus bi form, we write it as 4 plus 0i. 85, to rationalize the denominator, the original was 5 over 3i. We just simply multiply the top and the bottom by I. If you think of I as a radical, it's radical negative 1. If you think back to how I rationalized the denominator, let's say if this was radical 2, I would just multiply by radical 2 over radical 2. So since I is a radical, it's radical negative 1, I'll just multiply the numerator and denominator by I. So I get 5i over 3i squared. And again, I squared is just negative 1, so I have 5i over 3 times negative 1. And so I have negative 5/3 I. There is no real part, so I sneak in the 0 if we're forced to write it as a real plus an imaginary part, 0 minus 5/3 I. For problems 89 to 95, there's some notes that you have to look for. A key thing in those problems is to notice that I to the fourth is equal to 1, because I to the fourth, I can think of it as I squared times I squared, and we know I squared is equal to negative 1. So we have negative 1 times negative 1, which is equal to 1. So I to the fourth is equal to 1. And I'll take advantage of that for doing problems with I raised to a fairly large number. And here's how you can do it. You want to write it as a multiple of 4 times something else. So for instance, how do I do I to the 21st? Well, I write it as I to the 20th, 20 being a multiple of 4, times another I. 20 plus 1 is 21. The reason why I don't want to put this as a multiple of 4, because I know this is always going to be a 1. Okay, because now I to the 20th I can write as I to the 4th to the 5th power. And I said back up here that I to the 4th is equal to 1. So I have 1 to the 5th times I. Well, 1 raised to anything is 1. So I just have 1I or I. And likewise over here, I to the 27th, I want to write it as a power of a multiple of 4, meaning 24. So I to the 24th times I cubed. And I to the 24th, I can write as I to the 4th to the 6th power times I cubed, which is I squared times I. And I to the 4th is 1. So I have 1 to the 6th power. I squared is negative 1. So that's 1 times negative 1 is negative 1. So I just have negative I. 99, 2 minus radical negative 16 times 3 plus radical negative 4. Square root of a negative, make that come outside as an I. Make that come outside as an I. So I have 2 minus I radical 16 times 3 plus I radical 4. Square root of 16 is 4, so 2 minus 4I. Square root of 4 is 2, 3 plus 2I. And now this looks fairly normal, that's just regular FOIL. So I'll go first, outer, inner, last. The first is 6, outer is 4I, inner is minus 12I, last is minus 8I squared. Once again, anytime you get I squared, change it to a negative 1. So 6, 4I minus 12I is a negative 8I, then negative 8 times negative 1, and that's the same as plus 8. So this is positive 8 plus the 6 is 14, so 14 minus 8I. 107 is a little bit tricky. The original problem was 4 over 5I to the 35th, and then I realized that if this were I to the 36th, I to the 36 is what I want because 36 is a multiple of 4. So how do I force this to be a 36? I multiplied the numerator and denominator by I, so I have I over I. So that gives me 4I over 5I to the 36. And I know that I to the 36 is going to be 1 because I can rewrite this as I to the 4th. In other words, it's a multiple of 4. So it's I to the 4th to the 9th. And I know this is 1. Back over here, I to the 4th is equal to 1. So I have 4I over 5 times 1 to the 9th. Of course, 1 to the 9th is 1. So I just have 4/5 I, or writing it in the form of A plus BI. The real part is 0, so 0 plus 4/5 I. Finally, from 113, 4 minus 8I squared, I will use the fact that A minus B squared, the shortcut was A squared minus 2AB plus B squared. So using that over here, A squared is 4 squared, which is 16. Minus 2AB, it's minus 2 times 4, which is 8, times 8I is negative 64I, plus B squared, so 8I squared is 64I squared. Once again, the I squared becomes a negative 1, so 16 minus 64I plus 64 times negative 1. This is negative 64 plus 16, negative 48 minus 64I is my answer. All right, so these are notes for our Math 60, Thursday, April the 9th, 7.7. That's the last section for Chapter 7. So tomorrow, April the 10th, will be the Chapter 7 exam. Again, it'll be open book and notes, but you're not allowed to talk to anybody for the Chapter 7 exam.